All right, so problem one, it tells us, we can get back up. Okay. Problem one tells us that stress concentration in bars occurs in the vicinity of abrupt changes in the bar cross section. And then it gives us all these curves, this graph for the curves for the different D over D values. So it tells us to for curves 1.2 and 1.02 to take 10 to 20 points so that we could draw those curves or plot those curves in Excel. So for each of these curves, you're just gonna have to look at the graph and estimate 10 to 20 points on the graph. I did 10 here for each of them. So eventually, this is actually just the trend line. This line right here is just a trend line. I plotted the points and then got the trend line and then made those points invisible. So you can't see the actual points, but you can see the trend line. So that's what this is. So for each of the points, what I did was first I picked the K values because I thought that way it would be easier. So for the curve 2, what I did was, if I could scroll over, and it was kind of annoying because they're all so close together. So for curve 2 here, I put the endpoints first. So the endpoint would be at 0.2, and then I just estimated where the K value would be. So how I did the estimation here to make it slightly more accurate than what it would be just. So I drew little tick marks here. So I drew one. I split this thing into, hold up, just drawing so wrong. I split each of these thingies into 8 sections here. And then, so this is for each of these points, by the way. So for 0.2, RD equals 0.2, I estimated it was 1.48. I didn't really want to get too specific there because it doesn't really matter. It's just the endpoint. And then for the first point on this second graph, for this second curve right here, it goes all the way up to 3. And here's where the tick mark method thingy comes into play. So you see that this curve, it goes up into here, and then it stops right there. So we have to figure out what the RD value here is. So what I did, this little 8 tick method here, you pretty much estimate at what tick this would be at. So I estimated that it would be 1 tick over from 0.025. So I just took a little formula here. So 0.025 plus, and then this is going to give us the RD value. So 0.025, and I estimated it would be 1 tick over. So the value of one of these ticks would be the value of the length of this section right here. So 0.025 divided by 0.025 divided by 8. So this would give us the length of one little tick here. So if it's 0.025 and then plus 1 tick over, it would give us whatever this is equal to. So the RD value here would be about 0.028. And that's what I put here, 0.028. So when the K equals 3, the RD value is about 0.028, sorry. And then I continue doing that for, if I could scoot it over, wrong thing. So I did that for 2.8 as well. So let's do 2.8 real quick. So for the same curve, You go up until you get to this line, which is 2.8. And here, I think I estimated 2 ticks over. So if you just look at this and imagine 8 invisible ticks here. So 1, 2, just imagine 2 ticks over. So you take the same little equation. So this is 0.025, so this line right here, plus 2 ticks over. So you would multiply this by 2. This is the size of 1 tick. And then if you add 2 ticks, it'll be 2 times that. And then I got that value here. So 0.03125. And that's what I put here. So 3125, but it rounds up here. So I just did that for every single one of these. It was a little tedious, kind of annoying, but I think it worked out in the end. You got sort of straight lines here for the trend lines. And honestly, you don't have to be as accurate, but I honestly don't even think there's an advantage to being more accurate, but it just gave me better results, I think. I don't know. So now that you have all these points here, if you go my route, which is using the power fit, I think I have the table here. This one. So this is table she gave us for one of the classworks. Where okay, so for it's called linear regression. So what we do here, where we find the coefficients, is called linear regression. And linear fit obviously is these linear equations. They don't require linearization because they're already linear. But for these equations, they're not linear, they're not straight lines. So you have to linearize them, which is what this is. So I put a power fit. Actually, let me see if I can get these the points back that I got. This is this one. So here you see I made the markers invisible. So there's no markers for this series here. Let's just put it automatic here. So those are the points I got. Here it kind of moved down a little. But so what you do here is just go here to trend line and more options, and it tells you, it asks you which series you want to put a trend line for. And these are the trend lines right here. Actually, these are not the trend lines. These are the points here, but we'll get to that later. So these are the points that I got here. So for d over d equals 2, this is the points I have. So we want to add a trend line for those points. You see linear gives you a straight line here. Log kind of works, but it kind of dips down here. You know what I'm gonna do? You see it kind of dips down at the bottom here, and it doesn't really follow this point right here. So, and I honestly didn't want to add like 6 orders here, like Vivian did. Like it works, but it's just a lot more work, honestly, in my opinion. So I just went with the power fit. I felt like it fit the line best, like these points that I have here best. So I went with that. And obviously I made the points invisible. So all you see is the trend line. If I can go back. So all you see after I make them invisible again. Okay, there. So I pretty much deleted the markers for this series and only left the trend line here. So that's what you'll see here. And you also have to add the equation down here. Display equation on chart and display R squared value on chart, because she asked us for that. So you do that for all 3 of them. So now you have your equation, you have your lines. Now you have to move on to the regression. And here, if you're using power fit like I did, you have to linearize the equations. So let me try to explain this the best I can. So linear equations are in the formula, are in the form y equals b equals mx plus b, sorry. All right, right? So you see this formula right here, that is not in this form right here. So what you gotta do is get this equation into this form. So by taking the log of both sides, you get ln k0. This would eventually turn into your b here, and then log of this, which would give you this right here. So this is called linearization, and everything is on this right here. So to linearize exponential fit, log fit, and power fit, you do these steps here. So don't worry, I'm still gonna explain this process while I'm doing this here. So for this curve for 2, you have to, and it says here, take the natural log of all x and y values. So for power fit, to linearize power fit, you have to take the natural log, or ln, of the x values and the y values here. So if you look at this formula right here, this is the natural log of this value right here, and I just dragged it down to get all the other values here, the natural log of all these other values. And here you could just do the same thing. You just drag over. Oh, shoot, wrong thing. You could just drag this equation over right here, and they'll give you the natural log of, if I can select it here, of this value. And then you just drag it down, and then you get the natural log of all the other values. So now you have ln of r over d and ln of k, which are x and y. So now you have ln of y, which is ln of k here, and you have ln of x, which is this one right here. So now what you need, now you have it in this form. So you have ln of k, which is your y, equal to b0, which is your constant, plus b1, which is your coefficient of your independent variable here, which is rd in this case. So now you use linear regression to find these coefficients. So you take this as if it would be x. So this would be your x, and this is your y. So what you do here is you have a 1 that'd be for your constant, for your constant, and this is for your x. So imagine this would be x here. This is x and this is y. So these are your x values here. So you pretty much just copy this over to here, and the y values. So you copy this over to here. So now you just go to the data analysis, regression, and for the y range, it would be these values here. All right, and for the x range, it's these values right here. You're including, if you include the labels, you have to put the labels here, and it doesn't ask us for residuals right here, but just put it there just in case, I guess. And you press OK, and it gives us these values here. So coefficients, you copy these over to your sheet here. So wait, hold up. Something happened here.
It looks like that's the one for the second one. Like the bottom coefficient is the same.
Oh, that's nice. So
maybe you clicked the wrong one.
Yeah, maybe. Let me do it again, actually. Let's see. Input Y range. So it's this, I think. How did I magically? I'm pretty sure I selected the other one, but it's fine. So yeah, that was the problem, I guess. So you paste it there. Now this should be the same as this. So you do regression, linear regression on these. So I could find my pen here. All right, so now this is the intercept. So this is your B0. This right here is your B0, this value right here. And this right here is your coefficient for ln. So this is b1. This is b1 right here. This one right here. All right. But if you could see in this sheet right here, b0 is equal. Oh, but sorry. If you go back to the equation here, you see y equals k0. So this is what this number is right here. K0 is for this curve right here. K0 is 0.849. So if you go here to find K0, the ln of K0 is equal to B0. So what you do is, erase this. So if B0 is equal to the ln of K0, you have to take both of these and put them to the power of, not to the power of E. You take both of these and make them the power of E here. So if you should know, I think, e to the ln is equal to 1.
It cancels, right?
Yeah, it just cancels here. This cancels here. So e to the b0 is equal to k0. So if you want to find this value right here, k0, you have to take this value right here and put it to the power of e. So you use the exponent function here, which would pretty much take this value and make it the power of e. So e to the b0 gives you k0. So k0 is equal to 0.8489, which is, as you can see, the same value as this right here. Now, you do that for all these other ones. So if you want to do the linear regression, you get these coefficients. And as you can see, this is this. I mean, this is equal to e to the power of b0, which is this one right here. So now you have k0 right here. You have k0, which is this. You have k1, which is, hold on. K1 is equal to b1, which is this right here. This one right here. So now you have all the coefficients, all the parameters that you have in this equation. So you see it's 0.849 times x to the negative 0.341, which is the same values we have here. 0.8489 times x, which would be part of the equation, to this power right here. So now you have all your numbers here. And I think you might need to know how to do this. If she tells us like specifically to use a certain fit, like you could use linear fit and have like a polynomial to the 6th order or something, but she might ask you to use a specific fit, like use a power fit, and then you'd have to know how to linearize it and use least square regression on a power fit, which is what this is. So now you do that for all 3 of these, right? So technically you have the equations for all 3 of these curves. So for this curve, you see right here, the equation is 0.8929 times x to the negative 0.274. And that's the values we have here, 0.89 and negative 0.27, which is 274 right here. And for this one as well, the equation is 0.7384 times x to the negative 0.22. And that's what we have here. Yeah, 0.73884 or 83 right here times this, the exponent, which is the same as a. So now you should have the equations for all these trend lines based on your data points here. So the last thing it asks you to do, okay, this one here. Last thing it asks you to do was, so we've plotted the data, which is obviously the markers, they're invisible now, but you plot the data and select the best trend line. So in this case, we selected power fit. And it says one equation for each curve. They don't need to be similar. So I think they don't have to be the same. Like you could do power fit for this one, you could do polynomial for this one, you could do linear fit for, actually you can't do linear fit, but you could do exponential for this one. It doesn't matter. So you have to show the trend line equation, which is what we did here, and R square value. Then you find the trend line coefficients. So pretty much the equation of, you find these coefficients here for all these equations and compare those with what you found here. So these should be the same as these right here. Then you validate your numerical models by evaluating this x value for the curves. So for the curve 1.02, you should evaluate it at 0.025 and then compare that value to what you see on this graph right here. So if we look at this graph, it stops moving around. So if we look at this graph right here, and we see for this curve 1.02, this one right here, if we evaluate it at 0.025, which would be this line right here, just this line, 0.025 is right here, and we go up to 1.71. So 1.7 would be right here. So 1.71 is about there. So as you can see, it matches up. This matches this graph right here. And for 1.2, which would be this one right here, this one, the second one here, not this one, the other one, this one. 1.2, if we evaluate it at 0.15, so at this line right here, and we go up to this curve right here, we should get about 1.5. And according to this, we do get about 1.5 because it's between 1.4 and 1.6 here, 1.5. And for curve 2 here, should be the second to last one here, we evaluate it at 0.225. So I kind of skipped that step there. So here, sorry, you have the equation of the power fit. You have K0 is this one and K1. So if you want to evaluate it at 0.025, you have all the required coefficients. So what you do is you take K0, which will be this value right here. Sorry, we're on the wrong curve. So for the curve, let's do this curve, sorry. So if we take this curve right here, you see we have, this would be a K0 times the X value, which in the case is R over D, the X value to this power, which is K1, which would be right here. You see K1 is B1, and that's the coefficient here. So you take all those and you take the equation for this curve 1.2 using these coefficients, and you evaluate it at this X point or this R over D point, and you get this point. So after you do that, then you compare, but that was my bad. I kind of skipped that. Then you compare and you look at these, does it match up what's on here? And that's number one pretty much. I don't know if you guys have questions.
I mean, my only question is how do you validate the numerical model? Like, I know you just did that and you explained it, but is there a way to show that, like, oh wait, oh my god, never mind.
Like if you can magically pop these points in here and graph it on here using Excel, then I guess that would be the best way. But
No,
you can
yeah,
only
never mind.
you can
I
only
got
look
it.
at it. You can only look at it, I guess. And Maria?
Yeah, so to get the K, we need to do the linear regression package thingy to get the coefficients.
Yes.
K0. But my question was, because I was turning on when you explained that the data to get the regression, we get it from the points that we choose, right?
Yes.
It was a little lost in that part. You calculate the logarithm, I don't know how to say it.
The natural log here.
Yeah.
So you have to look at this table here. It's probably best to write this down. You might need it for the test. This right here.
Oh, okay.
This is table, I think 6.1 it's called. Table 6.1. I think it was classwork 6. I'm not sure. But I mean, she explains how to do linearization in that, and I think in that video. So even if you don't understand it here, you could just look at that video there, so you might understand it more. So it tells you, it gives you all the steps here. So it says take the natural log of all x and y values prior to performing regression. So to perform the regression here, you need the natural log of the x values, which in this case is r over d, and the y values, which in this case is k. So you take the ln of r over d and the ln of k. So you use this function. Wrong one. What the heck? ln of this value, the x value. And then you could just drag that equation down, right? And you could also just like drag it over because it's right next to here. So using the relative referendance or whatever it's called, you drag it over, and now you have this right here is the natural log of 3. And then you just drag it down, and then you get the natural log of all these other values right here. Right?
Yeah, thank you.
So, yeah. You get it from there?
Yeah, I understand. I just was confused where that was coming from.
Yeah, that's fine. So for number, do you guys understand part number 1?
Yeah.
I mean, problem 1?
Mhm.
All right. So problem 2, this was, I mean, I guess it was simpler than I guess it.
Where's the F coming from?
Yeah, that's okay. So let me explain. So we have this formula right here, right? So usually if it tells you to find, to use solver or use goal seek, they're going to give you a y, and then it's has a whole bunch of x values, right? Let's see, like that or something. So you're going to ask solver to change these x values to give you y, right? But in this case, they're asking us to find f here, but it's not by itself out here. It's on both sides of the equation. And if you were to solve for f, so get both of these f together on one side, it would be a little more difficult than you'd probably want it to be. So here we're going to use solver or goal seek. It doesn't really matter. We're going to use solver or goal seek here. And you're going to put the values here that they give you. So they give you d is the pipe diameter, already indicates the flow Reynolds number. So they give you that d equals 200. So we have here. Roughness is equal to 0.055. So what we have here. And then Reynolds number is equal to 650,000 right here. So here, let's do it as if we, actually, let me keep that there. Let's do it as if we were just guessing right now. So it gives us that for friction factor, typical values for friction factor are 0.01, 0.001 to 0.01. So we're just gonna guess, I don't know, 0.005 or something. So you just get 0.005. And here you would plug in the equation here. So you do 2 times log. Let me write it out actually. Okay, so equals, before you do that, actually, give me a second. What you're gonna do is move this over to this side here. So it's gonna be equal to 0 equals this. So just imagine that here, minus 1 over f, the square root of f. So now we have the entire formula on this side and set that equal to 0. All right. And that's what we're going to tell solver to do. So we're going to write all this in here, in this little formula space right here. And then we're going to tell solver that we want that to equal to 0. So tell solver that make that equal to 0 by changing the f value here. I don't know if you get what I'm saying here.
Yes, I'm following.
So when solver makes that equal to 0, it's going to give you the f value that makes that equation true. And that would be your f value, pretty much. So we're going to set that equal. I'm sorry?
It is easy. I just was getting confused. But it looks easy now that you explained it.
All right, yeah. So we're gonna write this whole equation down. So all this plus minus this over here, move it to the other side. So -2 log the equation, log the function log here, and it tells you that it's a log base 10. So there's one specifically for a log base 10. And then you add parentheses. Honestly, if you don't know whether to add a parentheses or not, just add it, because if you don't and then it messes up your number, then you'll have a hard time figuring out where that it's messing up. So just add parentheses everywhere. Everywhere where you see, like for example, right here, 3.7 times D, wrong one, times D. So if you were not to add a parentheses here, it would do C9, which is the E here, E times E divided by 3.7 times the D value here, which you don't want that. You just wanted to multiply 3.7 times D and then divide C9 by whatever you get here. So just make sure the parentheses everywhere. Plus 2.51 divided by, and here we're gonna have parentheses again, RE times the square root, there's a square root function here, square root of F. And then you close the parentheses again there, and then you actually close it again. And then, I mean, after that, you close it again for this parentheses up front. So make sure you have the same number of parentheses everywhere. And then you subtract parentheses if you want or not. 1 divided by the square root of F. And you close that parentheses there. And now you have this entire equation. Hold up. Did I mess up somewhere? Log 10, C9. I think I messed up somewhere.
Maybe count the parentheses.
Yeah,
I'm
honestly.
doing that right now.
You know what I'm gonna do? I'm gonna copy this and see where I went wrong.
It might be the -2 log thing.
Yeah, so I'm gonna copy that. That's what I put. So if you go back to where I had it correct.
Oh, you need to put times. You didn't put it before. Oh, you got it -2 times log. You
Okay,
hadn't
so
written
now
that.
this is right. This is correct. Oh, that's right. Yeah,
Okay.
you're right. Yeah. So as you can see, I didn't have 2 times log right there. So don't forget your multiplication symbol there. It's very easy to make a mistake here and then just get frustrated. So you press enter, but let's go back. Actually, you can't go back. So after we've written that whole formula, we got 0.05, let's say, for example. So now solver tells us that all that is equal to 4. But if we want to find f, we got to tell solver that all of that is equal to 0. Because if we move this over, that should equal to 0 here.
I got
So,
a different number.
Yeah, I'm guessing right now. So this is just a guess.
No, but I mean, like in the solver part, you got 4. I got -6.36.
Maybe because you put a different f value here.
Oh shoot, yeah. There, I
Yeah.
have an extra 0.
It doesn't really actually, does it really matter? Yeah, it doesn't
Okay,
really
I
matter
got
because
3.6. It's closer to 4.
yeah, I just don't have that many x values here.
Got it.
We could just add there, you see 3.6. I just didn't have the same number of decimal spaces. So now we have 3.60 here. So what am I doing? All right. So we want to tell solver, make this equal to 0 by changing the F value here. And once solver makes this equal to 0, we should have our friction value here. We're going to go to data. So solver. So you want this cell right here to equal to 0, because that's what makes our equation equivalent, right? By changing the F value here. And
Wait,
nonlinear.
I'm so sorry. Can you start again with the set objective?
Yeah, so we have a whole formula here, right?
Uh-huh.
And if we move this over to here, we should have equals to 0 on this side, right?
Oh, okay, I get it.
So we want solver to make the entire equation equal to 0 by changing the F value here. And once it makes the equation equal to 0, it should give us the F value. Yeah.
Okay.
So putting twice there. Set this equal to 0 by changing the F value that we have here, which right now is at 0.05. So if we put OK, you press OK, and it should give you the value here. Now, the whole equation is equal to 0 now because F is at this value here. So you could also check that value here. So I put this side. What does this side equal if F equals 0.015794, right? So 1 square root of the F value here. And it gives me 7.957. So if we plug in F on this side, it should equal the same thing as what we get on this side. So that's what I did here. -2 log base 10 times the E value divided by 3.7 times D plus 2.51 divided by RE times the square root of F. So if we do this and our F value is correct, both of these sides should be the same, which they're about the same, 199,197, because it's not always accurate, like 100% accurate here. It's going to give you a little error, but it's about the same. So this is our F value. Any questions?
For some reason, the part where it says solver for me says -2 point whatever, but my F is the same as yours. Wait, and I put it set to 0.
Negative what?
-2.04 to the -6 power.
Yeah, e to the -6 is just that's very
Just
small.
0.
Yeah, it's very small. So it's not
Okay.
always going to be exact. So
Should I leave it like that, or
I mean, yeah, she knows. She even mentioned in one of the classwork is like if it's like to the 6 or to the 7, it's to the -6 or -7, then it's fine because it's pretty much 0.
okay?
I don't know if I could do it here if I put it scientific or something. Yeah, you see, it gives me negative.
Oh, okay.
Yeah.
Got you.
So if I put it in number and I add the decimal places here, you see it's like all the way down here.
Yeah, I see.
Yeah. It's pretty much 0. So that should be our F value. That makes this both sides equivalent, as we could see here as well. Any other questions, Maria?
No, with that one, I'm good.
All right.
Yeah.
So for number 3, we have this data right here that you have to copy from here, this data, and we have this equation right here, which it gives us right here. So I think it was classwork 6. I'm not really sure. No, it wasn't classwork 6. Well, point is, she's done this before, where this same exact equation actually. That it was for the one with the plate, with the edges being different temperatures, and you have to figure out the gradient. So she did the same exact process, where you have this equation and you have to find out the coefficients. And you use least square regression for this as well. So you put your coefficient 1 always here. And for your x's, you have to take all these data points and put them on here. So what I did was do 0, 2, 4, 6, 8, 10, 12 for y equals 0. I note this is y, this is x. That's at least that's how I put it. This is x and this is y. So when x equals 0 and y equals 0, it equals 4, right? So I put all these points here: 0, 0, 2, 0, 4, 0, 6, 0, 8, 0, 10, 0, 12, 0. And that's it, this entire first row right here. And then I went to the next row: 0, -1, 2, -1, 4, -1, 6, -1, 8, -1, 10, -1, 12, -1. And then after I've done with that y row, I started again: 0, -2, 2, -2. So I have all these points here, all these right here on here. And now you have C3x squared, C4y squared, and C5xy, and that's what you put here. So you take this x value and you square it, and then you just drag that equation down. Here you take the y value and square it, and you drag that equation down. And then for xy here, you multiply x and y, and then you drag the equation down. So now that you have all that here, this is these are your x values, because these are your independent. So in here you have 3 variables technically. You have h of xy, which is your dependent variable, and you have your independent variables, which are x and y. So these are like your x values, at least in terms when you're doing the regression. These are your technically like your x values, or your independent variables. And these are your dependent variables, which are your y variables, which is what you get in the center here. So for 0, 0, you get 4. And for 2, 0, 2, 0, you get 4 again. So for 6, 0, you get 6, 0, you get 2.24 right here, 6, 0. So that's what you do here. You just copy this, copy. It depends on how you do it. So I went this row first, then this row, then this row. So if I just copy this row right here, copy, and then paste special, and transpose here, you should get these values here. And then just move on to the next row. Copy, then paste special, and then transpose.
You know, you don't have to do that every time there is a transpose button.
There is a transpose button.
Yeah.
Where?
Oh, I can show you, like, do like the next one if you want.
Yeah, hold up. Let me just put my brightness up because it's on battery saver. All right, so select the next one.
So like, yeah, let's say you
copy.
grab that one, copy, and then highlight what you're gonna transpose it on.
I think it's up to here. Yeah, there.
And then right click it. And you see the paste options, the one with like the arrows, click that one.
Oh, okay, cool. Thanks for that, I guess. So you do that. Depending on how you did the values here is how you're gonna put the x values on here. So after you put all the x values, right? After you put all the x values here, then you could do the regression. So you go to data analysis, regression. That's okay. And for your y range, it's going to be these right here. This is your y range, and you can include labels or not. It doesn't really matter. And then for your x range, it'd be all these right here. Then you don't have to put residuals, but you can. She doesn't really ask for them. She might ask for them on an exam, so make sure to read that if she does, and just press OK. Must have the same. Hold up. So that's a y range. Did I not highlight one row by accident? Okay, there. I must not have highlighted a row by accident. So now you have these coefficients here. Copy, put them over here. And I think she also asked for the R squared. So you determine coefficients and R squared value. So this one, the R squared here, you copy that as well. You put it here. So now these are your coefficients. So for this is your intercept. So C0 is equal to 4.2. C1 is equal to negative 0.34. Then C2 is equal to 0.1 and then so on. This is C3, C4, and C5. So now that you have, now that you have that, you have your coefficients and your R squared value. Now you have an equation. So you could plug in any values on here and get a result, right? So technically these are just an estimate because they're not going to fit exactly. You see the R squared value is 0.94. Since it's not 1, it's not going to be 100% accurate on the data, but it's going to be pretty close. So
Wait, how'd you get that graph?
yeah, I'm going to explain that now.
Oh, okay.
So it says display your results on a contour plot. I'm guessing this was a typo here. This should be down here after everything else here. It says, now that you have an equation, you can create a 2-dimensional array as the one below. So like this one, but showing the pressure head for more locations with X values between 0 and 12. It is suggested you find pressure head every 1 meter. So every 1 meter, 0, 1, 2, all the way to 12. So instead of it being 0, 2, 4, 6, 8, 12, 10, 12, it's 0 to 12, but counting by ones. And then I think I kind of messed up here. I should have added more Y's, like counting by 0.5. You see, and Y values between 0 and -4. So I messed up here. I probably should have added more. Probably going to go back to do that. So 0, 0.5, -1, 0, -0.5, -1, -1.5, and so on. So it just tells you to add more values here. So what you do is you take these values, you go to insert, recommended charts, because contour plot is not on here. So you go to here, all charts, then you go to surface. You could do like 3D or 2D, which is what it's asking you to do. It's telling you to do a contour plot. So you go to contour and you click OK. So now you have a contour plot. And if you want more gradient, I think you go here. Hold on. Let's select the axis. No. There. So when you select the axis, you go to these settings right here. Axis options, I think. Or is it tick marks? I don't even know. So, I mean, how she showed us to do it was to change the chart type, change it to a surface plot, 3D surface. And then here you select this axis right here. And then you change the units to something smaller. So like 0.2. And you should have more gradients here. And then you change it back to a contour plot. I read somewhere online that you can change it without changing it to a surface plot, but apparently I didn't read correctly. So that's how you have more gradients if you want to. And pretty much that's what it's telling you to do. And then this sentence should be here last, and it says display your results in a contour plot, which is what's right here. And that's it.
Woo.
Hooray. I'm going to go back and add more Y values here. But
Do you have to though?
I mean, it says to add more.
But how do you get those other points?
All right, so I should explain that as well. So let's say I change.
Can you pause just like 1 minute? Because I really have to go to the bathroom.
All right, yeah, that's fine.
Okay, hold on, super quick.
So Maria, you getting it?
Yeah, I just have the same question as here. All the other points when you.
Yeah. Oh, I'll
Yeah.
explain now. I kind of skipped over that.
I know I'm gonna get confused in the first part, so be ready for my questions in the group chat, okay? Because I'm gonna try to do it after this, but I feel I'm gonna get a little confused.
All right.
Okay, I'm back. You can go ahead. Thank you.
All right. So probably should have explained this earlier before telling you to plot it, but so now we have no plots, no points here. Right? So we have this equation, and now that we have all the coefficients, we could evaluate this h function at any x and y point. So let's say we want 1, 0, which is not on here. 1, 0 is not on there. So we want 1, 0 here. Okay, so we set that equal to, right? So we follow this equation along with these coefficients here. So this is 0. Let me write it down actually. This is C0. This is C1, C2, C3, C4, and C5. Okay, these are all your coefficients here. So this is equal to C0, we're following this equation here, C0 plus C1 times X, this is your X, plus C2 times Y plus C3 times X squared plus C4 times Y squared plus C5 times X times Y. And that should give you what this function is at 3.10, which is 3.87, sorry. So now you could just rewrite that function for every single one of these here, but that would be not fun. So what you do is you make sure that you lock all your coefficients because you don't want those moving even when you drag it side to side. You don't want it moving anywhere. So you go F4, you lock all these K's because these are already coefficients. You see they're on the K column. So anywhere where there's a K, those are your coefficients here. So you want to lock all those here. Now, if you want to move it over and have your X values follow, you want it to move to the side. So you want it to change column, but not up and down. So for 07 here, that this is your X right here, 07, you want it to move it side to side. So this, you want this to change, but you don't want this 7 to change. Because if it changes, then it's no longer your X now. So you just lock the 7 here. So everywhere where there's an 07, you lock the 7. Now for your Y's, it's the opposite. You want it to move up and down, but not side to side. So you want to lock the column, but not the row. So you lock the M, but not the 8 here. Lock the M, lock the M here. So now your function shouldn't change. So it's 3.87 here. Yeah, I mean your answer. But now you could take it down. You can take it over and then drag it over this way as well. And it should just autofill, you see. You can also check it here. So you're still using the same coefficients, but now it's using -4 and 12 here. You can check this one as well. It's using 11 and -2 and still using these coefficients. Do you guys get it now?
Yeah.
Yeah.
That sounded kind of iffy.
Oh, I see. So you're putting like different X values and you
Yeah,
can
so
add them.
it tells you to add X values. So you see, you could just, let's see, negative 2.5, negative 3, negative 3.5, and it's just autofilling.
I see.
I didn't even know it
And
did
then
that.
you create the chart based on that. Or
Yeah.
no?
Yeah, so you would change, let's see, you could just actually just drag it down like that. Yeah, now your chart changes.
Oh, okay.
Yeah,
Wow.
But it looks the same to me.
yeah, it's about the same because it's the same range. It's from 0 to -4, but I added 0.5, 1.5, 2.5. So it's the same range, but it's just there's just more points on here. Yeah.
Hmm.
Let me
Okay.
think so.
I'm hoping I can remember everything you said for the past hour to do it myself. No, I think I got it.
All right. Just change my formatting there. So I think that's it.
And you're gonna post this, right?
Yeah,
Perfect.
just wait a little while because quality is gonna be a little bad for me.
Okay. Thank
All right.
you. I'm gonna
Yep.
start by myself.
All right.
Thank
Good.
you
Good luck.
so much.
Bye.
You're like the ultimate lifesaver.
Well, thank you.
All right, thanks, Rudy.
All right.
Do you think if I have like any questions, could I like message you?
Yeah, sure.
Okay. I don't think I will, but thank you.
Yep.
Bye.
Bye.